Hi everyone, and welcome to example problem video number 4. This video is going to tie together the first 3 videos that I've put out in the example problems type. And what this is going to be covering is how to approach problems which require you to use more than one of the chain, product, and quotient rules. So there's 3 main combinations that we're going to go over. You need to know how to do all 3 of these, and I just want to do, as a quick note, all 3 of these types of problems are relevant in the homework set that I assigned you, so this video is probably the most pertinent of all the ones so far. Okay, so to start off, I've already written out all 3 of the rules on this board, and I've set them aside. I'll be leaving them there for the rest of this video for you to refer to. And I'm going to be going over 3 problems, not in order of difficulty, but just 3 combinations of problems in this video. And let's begin with the first one. And this is actually taken from one of the very first problems in this week's homework set. So if you're struggling with the first couple of problems, this is the part for you. And the problem I'm going over this time is going to be asking you guys to find the derivative of 6x e to the x to the 4th. Okay. Now again, in many practical applications, you will not be told which rules you need to use here. Now all 3 of the problems I'm covering today will require you to use 2 of the rules I've written on the side. And if you want, feel free to pause the video for a little bit and try to see if you can figure out for yourself which 2 rules we're going to need to use here, and in which order. Okay, so the 2 rules we're going to need to use are, first, a product rule, and then second, a chain rule. Okay, how do we know this? Well, let's break down this problem. Let's break down this function into its component parts. The first thing that we see is that we have these 2 functions, 6x and e to the x to the 4th, which are being multiplied together. And then within this second function, e to the x to the 4th, we have an inside and an outside function. So the first thing that we're going to have to do is address this as a product rule, and then within that product rule, we're going to have to do a chain rule. All right, let's work this through. First off, let's just attack the product rule itself. So as usual, when I tell you guys to look at a product rule, I tell you guys to write this as f of x times g of x. And here we're going to see that f of x is equal to 6x. And g of x is going to be equal to e to the x to the 4th. And as usual, I tell you guys to, right off the bat, write out what these derivatives are. Now the derivative of f of x, if f of x is 6x, its derivative is just going to be 6. And then here's where things get a little bit weird. The derivative of g of x, if g of x is e to the x to the 4th, is not immediately clear. This is where we're going to need to use a chain rule. Okay. So let's try to break down g of x itself into 2 component parts. All right, first off, I'm going to move this a bit and shift this up here. And we've reduced ourselves to a different problem. We know that g prime of x is equal to the derivative of e to the x to the 4th. Now, e to the x to the 4th, for those of you who may have watched the video on chain rule, I've already covered how to do this problem in depth in that section. So I'm going to go a little bit faster here, but I'm still going to go through how this is a chain rule. So let's break this guy down. And we see that this has an outside function and an inside function. All right, so in order not to get too confusing, I'm going to call these functions, which I'm going to write out now, I'm going to call these out of x, which we see is equal to e to the x, and in of x, which we see is equal to x to the fourth. Now, as always, the first thing I tell you guys to do is to write out their derivatives. So out prime of x is the derivative of e to the x, which is e to the x. And in prime of x is the derivative of x to the fourth, which is 4x cubed. All right, now let's rewrite this by rewriting all of chain rule. We're told to find the derivative of out of in of x. And chain rule tells us that this is going to be equal to in prime of x times out prime of in of x. Again, I've just replaced the f's and g's with in and out because I do not want to confuse you guys with what I've called f and g just above here. All right, once again, I'm going to color code this so that you guys can see what I'm plugging in where. We see that in prime is in green. We see that in is in blue. And we see that out prime is what I have in yellow. Okay, so plugging everything back in, you see that we get here in prime of x is 4x cubed. Then we have a multiplication symbol. Then we have our out function, which is e to a power. And that power is going to be our inside function, which is x to the fourth. And this here is equal to our g prime of x. So this is what I'm going to be able to rewrite. I'm finally done with this part. I'm going to be able to rewrite all this in this section here. So I want to make this very clear that all of this is going to go up here. And we see that here for our g prime of x, we have 4x cubed times e to the x to the fourth. Okay. So now we're almost done. To avoid confusion, let me put a bar here. Let's finish off our product rule. This is the derivative of f of x times g of x. And product rule tells us that this is equal to f prime of x times g of x plus g prime of x times f of x. And once more, let me color code everything. We see that f of x is over here in blue. We see that g of x is over here in red. We see that f prime of x is over here in yellow. And we see that g prime of x is over here in green. So let's rewrite everything in the spot that it needs to go in and mind the parentheses. First, we have f prime of x, which is just 6. This is being multiplied by g of x, which we've written is e to the x to the fourth. Then we have an addition. Then we have g prime of x, which we have said is 4x cubed times e to the x to the fourth. And last but not least, we have f of x, which is 6x. And at this point, we have gotten our answer. Okay, so this may look a bit hectic, but I really want to remind you that all the work that I've done at the bottom of this screen was all to fill in exactly what we needed over here. This box here was the only place where we needed to do a little bit more work. And all of that additional work is what I've done at the bottom of this screen here. It was all to figure out what this g prime of x is in the product rule that we're using. So once you've done all this down here, which is all just a simple chain rule, then you plug that back in into the missing piece, and then you finish off doing your product rule. At that point, all you have to do is rewrite the rule and plug everything in the right place, minding your parentheses if you need to. All right. The two other problems that I'm going to cover today are going to look pretty similar to this. They are also going to be in sort of two parts in the exact same way. So hopefully you'll start to get the feeling for exactly what's going on as I'm doing these problems. Okay, let's move on to the next example. So the next problem I want to cover is asking you guys to do the derivative of, let's say, square root of x to the fifth minus 2 divided by natural log of x. All right. Again, the first step in all of these problems is to figure out what two rules you're going to need to use. So, and also to figure out in which order you need to do them. So feel free to pause the video and try to think on that yourself. Okay. So, if you see here, the very first rule, the outside rule, if you would, that we're going to need to use here is a quotient rule. We have two functions which are being divided one by the other. And inside this quotient rule, we're going to have to do a chain rule. And the reason for that is that the numerator in this fraction actually consists of two nested functions. So we're going to be doing a quotient rule inside of which there will be a chain rule. All right. So let's break this down. And as usual, I'm going to try to color code everything. Within the quotient rule, you need to identify your numerator and you need to identify your denominator. It is sort of standard to call the numerator f of x. And we see that in this case, f of x is equal to the square root of x to the fifth minus 2. And our denominator is usually what we call g of x, and that's equal to natural log of x. All right, the very first thing you should do at this point, every single time, should be to now write out, first off, what f prime of x is, and what g prime of x is. Now, g prime of x is straightforward. G of x is natural log of x, so g prime of x is 1 over x. But this time it's f prime of x, which requires us to use a chain rule. So we're going to need a little bit more space to work that one out. So down here, I'm going to write this out. We have f prime of x. And to find f prime of x, we need to take the derivative of the square root of x to the fifth minus 2. Now this requires us to do a chain rule. So it's important to identify the outside function and the inside function. In this example, you can see that the outside function, which again I will call out of x, is equal to the square root of x. In other words, x to the 1/2. The outside function, the thing that's happening in the outermost layer, is we're taking a square root. Now the inside function is equal to x to the 5th minus 2. All right, next off, we need to take their derivatives and write them out. If the outside function is square root of x, its derivative, out prime of x, is going to be 1/2 x to the negative 1/2. Meanwhile, if the inside function is x to the 5th minus 2, then its derivative is going to be 5x to the 4th. All right, so now let's rewrite chain rule. Now, chain rule tells us that when you're taking the derivative of two nested functions, which here I've called out of in of x, that this derivative is equal to the derivative of the inside function times the derivative of the outside function into which you plug in the original inside function. Okay, now let's color code these just so that we see where everything is going. We see that in prime of x is what I've color coded in green. We see that out prime of x is what I've color coded in yellow. And we see that inside of out prime, we have in of x, which I have color coded in blue. All right, now we just need to rewrite all of this. I said that in prime of x is 5x to the 4th. Then we have a multiplication symbol. Then we have out prime of x, which is 1/2 times whatever we're plugging in, which is then being raised to the negative 1/2. And the thing that we are plugging in here, mind the parentheses, these are important, is x to the 5th minus 2. Okay, now this here is exactly the f prime of x that we need up here. So let's go ahead and write that in the spot where it belongs. So I'm just going to rewrite in this slot exactly the answer that I got at the bottom here, which is 5x to the 4th times 1/2 x to the 5th minus 2 to the negative 1/2. And again, I want to remind you guys that this is coming only from the work that I did down here. All of what you see at the bottom of the screen was just to find the derivative of f of x that I need for my quotient rule. All right, so the next step is going to be to rewrite the quotient rule, as we usually do. Here we are being asked to find the derivative of f of x divided by g of x. And quotient rule tells us that this is going to be the derivative of f times g minus the derivative of g times f, all this over g of x squared. All right, once again, let's color code these so that we know where everything goes, and then all we have to do is plug in. We see that f prime of x at the start is what I have in yellow. G of x shows up in two spots, and that's what's in blue. G prime of x up here is what we have in green. And last but not least, f of x up here is what we have in red. All right, let's try to rewrite this in the space that I've got. Okay, let's make this guy a little bit smaller to give myself a little bit more room. And let's start plugging things in where they need to go. So I am picking up from this line, just to be clear. Let's do this over here. I have this big equals sign, and mind the parentheses. So first up, we have f prime of x, which we have said is 5x to the fourth times 1/2 of x to the fifth minus 2 to the negative 1/2. Okay. Next up, we have g of x, which is natural log of x. Next up, we have a minus sign. Next up, mind the parentheses, we have g prime of x, which is 1 over x. And last but not least, mind the parentheses, we have f of x, which is equal to square root of x to the fifth minus 2. Then we have a big fraction bar. And in the bottom, we have a function which is being squared. And this function is g of x, which is natural log of x. And we are done. All right, so it looks like a lot of stuff, and sure, it is a lot to rewrite. But again, these are the types of problems that are the reason why I insist so much that you guys write all of your functions out. Once you have written out what f of x, g of x, f prime of x, and g prime of x are, then even a problem as sort of ugly looking at this one becomes as simple as just rewriting everything in the spots that it needs to go in and minding your parentheses. Now, of course, to find this f prime of x, we needed to do all the extra work at the bottom, but that's why this problem requires 2 rules, and it needed to be done in 2 parts. Okay. Let's finish up and do the last example problem that I wanted to do today. And in this one, I'll be asking, how do you find the derivative of x divided by e to the x times natural log of x? Now, as usual for these problems, the very first thing that you need to do is figure out which rules you're going to need to use and in which order. Feel free to pause the video to try to figure that out for yourself. Okay, so we can see in this problem that the outermost rule that we're going to need to use is a quotient rule. We have 2 functions that are being divided one by the other. But we also see that within this quotient rule, we're going to have to do a product rule. All right, how can we tell this? Well, we can see that we have 2 functions, one divided by the other. However, when you take a closer look at the denominator, you can see that we have, in fact, 2 functions multiplied one by the other. Okay, so let's not worry too much about the product rule for now, and let's just write out the functions that we're working with for our quotient rule. All right, so as usual, we like to call the function in the numerator f of x, and we can see that in this case, this is just going to be x. The function in the denominator we like to call g of x. In this case, we can see that the denominator function is e to the x times natural log of x. Okay, as usual, I highly suggest at this point that you immediately try to write out the derivatives that you are working with. And if f of x is just equal to x, then f prime of x is going to be equal to 1. And then the question becomes, what is g prime of x if g of x is equal to e to the x times natural log of x? And we can see that here's where we're going to need that product rule. Okay. So let's move down to the bottom of the screen again to do this product rule. Okay, so the function that we're looking for here is g prime of x. That's what we want to find. That's what we're missing for our quotient rule up top. And we can see here that g prime of x is going to be the derivative of e to the x times ln of x. That's what we want to find the derivative of. Now we can see that this is a product of 2 functions. I like to do the first one in red and the second one in blue. All right, let's write these out. They need names. Let's call the first one h of x. And we're going to see that that is just e to the x. And let's call the second one j of x. And that's going to be natural log of x. As usual, immediately the first thing you should do at this point is to write out the derivatives of these two functions. If h of x is equal to e to the x, then h prime of x is also equal to e to the x. Meanwhile, if j of x is equal to natural log of x, then j prime of x is going to be equal to 1 over x. All right, at this point, let's rewrite this as a product rule. We're being asked to find the derivative of h of x times j of x. And product rule tells us that this is going to be the derivative of the first times the second plus the derivative of the second times the first. All right, let's make sure to color code all of these so it makes it easier to see what I'm plugging in. H prime of x we said is in yellow. This is being multiplied by j of x, which we have in blue. Then we have j prime of x, which I've color coded in green. And that's being multiplied by h of x, which I have color coded in red. All right, all that's left to do now is plug everything in the right spot and mind the parentheses if we need them. I see that we have first off h prime of x, which is e to the x. This is being multiplied by j of x, which is natural log of x. Then we have an addition symbol. Then we have j prime of x. I'll put the parentheses here because this is 1 over x. And that's being multiplied by h of x, which is e to the x. Now, once again, I want to emphasize that what we've calculated here is just the function that needs to go in this last slot here. It's that missing g prime of x that we need to do our quotient rule up top. So let's rewrite that up here. We now know what g prime of x needs to be. And g prime of x is going to be e to the x times natural log of x plus 1 over x times e to the x. Okay. We're almost done. All we have to do is rewrite this as a quotient rule. We're asked to find the derivative of a top function, which we've called f of x, divided by a bottom function, which we've called g of x. And quotient rule tells us that this is going to be the derivative of the top times the bottom minus the derivative of the bottom times the top. All this divided by the bottom function squared. All right, we're almost done. All we have to do is plug everything in, and as usual, let's color code all of these so that we know what goes where. F prime of x we color code in yellow. G of x we color code in blue. Now g prime of x, oh, I missed a g of x. There's another one down here. Don't forget that. All right, this is being followed up by g prime of x, which we color code in green. And last but not least, f of x, which we've color coded in red. All right, now let's plug everything in and finish all of this up. So first up, in the top, we have f prime of x, which is equal to 1. This is being multiplied by g of x, which is equal to e to the x times ln of x. Then we have a subtraction symbol. After the subtraction symbol, mind the parentheses. These are important. They matter. We have e to the x natural log of x plus 1 over x e to the x, and close parentheses. And last but not least, in red, we have f of x, which is equal to x. Then we have our big fraction bar. And in the denominator, we have a function which is going to be squared. And this function is our g of x in blue, which is e to the x natural log of x. And with that, we are done. Okay, so I realize these problems are somewhat more difficult, certainly somewhat more work, than all the problems that simply require you to use only one of these three rules. But it is important to be able to recognize the cases which require you to use several of them, and to be able to work through them in an effective and rigorous way. So again, I'm a big proponent of writing everything out that you need, and keep in mind, like we did in all three of these problems, that in any cases like these, the only sort of catch that you run into is that when you're writing out all of these functions for the first rule that you need to use, one of them is going to require you to use a second rule. So the second rule in all of these examples is what I've done on the bottom, and these are always just to fill in one of the missing blanks to finish up the problem. Okay, so once again, there are several of the problems that look like these on the homework set for this week, so I hope that these examples are helpful to you guys. And as usual, let me know if you have any questions. Let me know if any of the problems that look like some of these are still giving you guys trouble even after this video. And otherwise, I hope you guys are all staying safe and healthy. And that's it for today. Bye-bye.